Problem 37, page 326. Here we have a block M1 equals to 2 kilogram, and we have M2 with 6 kilogram, are connected by a massless cord through a pulley having a radius r equals to 0.25 meter and mass equals to 10 kilogram. These blocks M1 and M2 are allowed to move on a fixed block wedge. Here we have an inclined plane with angle theta equals to 30. Okay, the coefficient of kinetic friction, I give you mu kinetic, which is equal to 0.36 for the two blocks, M1 and M2. First of all, draw the free body diagrams. You have to put all the forces applied on M1 and M2 and the pulley. Okay, we have two blocks and the pulley. Okay, let's draw here before M1. In this case, we have a motion down. Okay, the motion will be to the right. This one is a positive direction, and this one is a positive direction. Okay, we can say plus and plus. Here we have the friction will be in the opposite direction to the motion, and here also is opposite to the motion. Here we have the weight mg and we have the reaction n. Here we have the weight and we have the reaction is up. About the tension, you know, here we have a pulley with a mass m. So when the pulley has a mass m, so the tension here we have the tension T1 is not equal to the tension T2. In the last chapters, the pulley was massless, so we had the same tension. But if the pulley has a mass m, so here we have T1 and here we have T2. Okay, here we have F1, N1, M1G. Here we have F2, N2, M2G. Okay, about the pulley, as you know, we have T1, T2, and we have the weight will be M times G, and we have the reaction R. Okay, we have mg and the reaction. I think it's all about the forces applied on each object. A. Determine the acceleration of the two blocks. We have to find A1 and A2. The tension T in the string on both sides of the pulley. Okay, we have to find A1, A2, and T. Listen, if you want to calculate A1, A2, T1, T2, for example, we have T1 and T2, here you must take every object alone. System 1, System 2, and System 3. Okay? In the case of M1 and M2, we have a linear motion. So we have to apply Newton's law. In the case of pulley, here we have a rotational motion. So we have to apply summation of tau equals to I times alpha. Okay? Let's start with M1. Here we take M1. M1, first of all, you have to know the positive direction. I take the positive to the right, like this. Okay? So, summation of F equals to M1 times A. First of all, you have to say A1 equals to A2 equals to A, and V1 equals to V2 equals to V. Why? Because we have a inflexible chord. This chord is inflexible. It's important, this point. Okay, F1, what we have? We have F1 to the left in the negative direction. We have T1 in the positive direction. Okay, here be careful. You have to write all the forces before. F1, T1, N1, M1G. Okay, equals to M1A. We do the projection. You can write the I and G on the same equation, or you can have two equations. For example, here about the x-axis, we have minus F1I plus T1I. About y-axis, we have plus N1G minus M1G. As you see, we don't have a motion in the y direction, so we don't have AY. We have M1, AX, I mean A, okay? We have A because A equals to AX square plus AY square. We don't have AY, so A equals to AX. We can put A. Okay. Here we have A I plus 0G. You can say A or AX. It's the same. Okay. You can write like this, or you can write minus F1 plus T1, this one, and this one, and the Y, N1 minus M1G equals to 0. Like this, it's okay. Two equations about x-axis and y-axis, and this one about x and y. If you want to write one equation, you have to put ing. If you want to write two equations, we don't need. You can put here I, or without. It's the same. Anyway, now, as you see, I want to calculate. Here we have a relation between T1 and A. I can find F1, which is equal to mu times N, equals to mu equals to 0 point, okay, we can put it mu equals mu times N. N from here, N equals to M1 times G. So we can write minus mu M1 times G plus T1 equals to M1 times A. This one is the first equation. Relation between T1 and A. T1 is unknown, A is unknown. Okay. First equation. Second equation about M2. M2, here it's important here. Look. I take only M2, this one. About M2, as you see, for MG, we have MGX and MGY. M2GX and M2GY. We can write minus F2, or we can say F2 plus M2GX plus M2GY plus N2 plus T2 equals to M2 times A. Okay, we have M2, F2, M2GY, M2GX, and N2. Okay, now about the projection. You put I, J equals to M2A. Okay, F2 is in the negative and T2 negative. F2 and T2. So here we have minus F2 minus T2. And we have M2GX is in the positive direction. So plus M2GX. What about N2? Here we have N2 minus M2GY. Okay? And here also we have A in the positive direction. A. Okay. Here we can write two equations, minus F2 minus F2 minus T2 plus, you know, in the case of inclined plane, M2GX equal M2G sine theta, and M2GY equals to M2G cosine theta. You can put it directly, and the angle theta is the angle of the inclined plane. So here we can write plus m2 g sine theta equals to m2a. Okay, and n2 equals to m2 g cosine theta. Okay, now we can substitute the value of n2 in f2. You know f2 equals to mu times n2. We can write finally minus mu times n2 minus t2 plus m2g sine theta equals to m2a. Okay, this is the second equation. It's a simple relation between T2 and A. Okay, this one is between T1 and A, and this one between T2 and A. We have one unknown, two unknowns, and three unknowns with two equations. So it's impossible to find the value of T1, T2, and A. We have to find the third equation to find the values. How can we find the third equation? We have to take the system of the pulley, this one. Here, as you see, we have T1, we have T2, we have the weight, and we have the reaction. So T1, T2, R, and mg. Okay, let's clean here. Okay, in the case of rotational motion, as here we have a rotation, we have to apply summation of tau equals to I times alpha. We cannot use summation of F equals to ma. Okay, because here we have only rotational motion. Okay, you know tau of R and tau of mg equals to 0. Why? Because mg and R pass through the center. Okay, you can say tau of R equals to tau of mg equals to 0. Pass through the axis. Here we have the axis. Here we have T1. Here we have T2, like this. And here we have mg, and here we have the reaction. So this one and this one pass through the axis. They don't have tau. What about tau of T1 plus tau of T2 equals to I times alpha? Here, look, in general, I take the positive direction is anti-clockwise. But okay, here I talked this the positive direction. Okay? As you see, T2 push the cord to the right in the positive direction. So you can write directly plus tau of T2. And T1 push the pulley in the negative direction. So we can write minus tau of T1 equals to I times alpha. And now we can write the absolute value of tau. You know tau equals to the radius times f. If we have the pulley here, here we have T1, here we have the axis, tau equals to r times t. Okay, and the same for this one. Here we have T2 equals to r times T2. This is the calculation of the torque of tau. So r T2 minus r T1 equals to I times alpha. So here, as you see, it's a simple relation between T1 and T2. Okay. As you see here, we have three equations with T1 unknown, T2 unknown, alpha unknown, and A unknown. So with four unknowns, we have a problem now. We cannot find the values of these parameters because we have four unknowns for three equations. What can we do? We can change alpha in terms of A. You know, A equals to alpha times R. Okay? Why? Look here. Here, the cord is passing through this point. So the velocity of this point equals to the velocity of M1, equal to the velocity of M2. And A of this point equals to A of M1 equals to A of M2. You know the relation between A and alpha, A equals to alpha times R. Okay? So we can substitute the value of alpha by A divided by R. Like this, we get three equations with only three unknowns. Now it's okay. We can solve the problem. We can calculate T1 from this equation. We put it here. We can calculate T2 from this equation and we put it here. And we can calculate A from the third equation. Okay? So from equation 1, we can calculate T1, which is equal to M1A plus mu M1G. From equation 2, we can calculate T2, which is equal to minus mu M2G cosine theta. plus M2G sine theta. T2 minus M2A. Okay, this is the second equation. We put T1 and T2 into the equation 3. Okay, we put T1 here and T2 here. We get finally R times T2. Okay, we can put it directly. We have minus R mu M2G cosine theta plus R M2G sine theta minus R M2A. This is the first one. Minus R times T1. T1 equals to M1A minus R mu M1G. All this equals to IA divided by R. Okay? From this equation, we can find the value of A. Let me clean. Okay. We can find the value of A. We can take A common. Okay. Here, A equals to minus R mu M2G cosine theta plus R M2G sine theta minus R mu M1G divided by I divided by R plus R M2 plus R M1. Okay, we have all the values, okay? Here we have R equals to 0.25, mu equals to 0.36, M2 equals to 6, cosine theta, we can calculate cosine theta equals to cosine 30, and okay, we have M2 sine theta equals to sine 30, and I equals to ICM plus MD square. You know ICM is given, and D is the distance between the center of mass and the axis, equal to 0. So I equals to ICM equals to 2 over 5 M R square. Okay. So if you do the calculation, we get here, no, here I equals to, let me see the value of I, because ICM is given, equals half MR square. you do the calculation, we get 0.301 m per second square. This is the value of A. We substitute the value of A in the equation 1, we get the value of T1. And in the equation 2, we get the value of T2. So A into equation 1, we get the value of T1, and A into equation 2, we get the value of T2. I give you the answer. So the answer is T1 equals to 7.6 Newton and T2 equals to 9.2 Newton. Okay, here I advise you to calculate each equation, the numerical answer directly. Okay, like this you can simplify the calculation. Anyway,